my name is Ghilea Raluca and I study at Colegiul Național Calistrat Hogaș-Piatra Neamț, Romania. The topic of my presentation is fractals. Fractals are some of the most beautiful and most bizarre geometric shapes. They are mathematical sets that exhibit a repeating pattern which displays at every scale. For example, if you take a small extract of the shape, it looks exactly the same as the entire shape. This curious property is called self-similarity. To create a fractal, you start with a simple pattern, then repeat it at smaller scales again and again forever. In real life, of course, it is impossible to draw fractals with infinitely small patterns. So why are we even remotely concerned with something that can only be achieved theoretically? After all, fractals clearly can't appear in nature. If you would zoom in further and further, you would eventually arrive at atoms and molecules, and the pattern would have to stop, right? But the truth is that there are many shapes in nature which are very similar to fractals. In fact, most natural phenomena exhibit fractal properties. Snowflakes, for example, can be modeled using fractals. You start with an equilateral triangle, then divide each side into 3 equal parts, erase the middle part, and substitute it with the top part of an equilateral triangle. If you repeat this procedure, you end up with a shape known as the Koch snowflake, one of the first described fractal curves. In reality, of course, the shapes of the snowflakes are also highly influenced by the temperature and the humidity of the medium through which they pass. Thus, it is impossible for any two snowflakes to be identical. Snowflakes, however, aren't the only examples of fractals in nature. Fractals can also be found in our own bodies as well. The branching of the blood vessels in our lungs and kidneys follows the same pattern, making it easier for the blood to reach each cell. Trees also use fractal branching in order to maximize the amount of carbon dioxide they take in. Other examples are ferns, broccoli, lightnings, clouds, peacock feathers, mountain ranges, shorelines, and the list just goes on. At this point, you may think that fractals are just beautiful patterns with no real-life applications. However, they also play an important role in technology. Fractals can be used to generate computer graphics or textures for computer games. The process can also be reversed and used for image compression. Usually, a picture is saved by remembering the color of each individual pixel. For large images, this can take up a lot of space, so we want to reduce its size, we want to compress it. Some parts of the picture may look similar to fractals, so instead of saving each pixel individually, a computer could try to find certain patterns in the picture and only save those patterns, thus saving a lot of space. So, you see, mathematics really is everywhere, from a tiny snowflake to even the human body, and it's all thanks to fractals.